All right, in this problem, we're trying to find the Kb, the equilibrium constant, for a base given the concentration of the solution and the pH. These numbers are written a little weird. They have to be. It's an artifact of how I have to write the questions in order for you to give me an answer that's in scientific notation. But the way my brain works, the first thing I'm going to do is go ahead and take them out of scientific notation since they're not that big or that small. 2.4 times 10 to the minus 1 is 0.24 molarity, and 1.121 times 10 to the first is 11.21. So the pH is 11.21. It is a basic solution, and the concentration of the base is 0.24 molarity. And we're looking for the equilibrium constant. We did a bunch of problems like this back in Module 4, where we were given some information about the equilibrium reaction and we had to find the equilibrium constant. And if you recall, we always had to set up an ice table, use the information that was given in the problem to complete the ice table, and then use the equilibrium values in the ice table to calculate the equilibrium constant. So this is just like problems we did in Module 4, except for we're using the vocabulary of acids and bases that we have just learned recently. So I've got a base. The fact that there is a Kb value that's not huge, and there is a Kb value means it's a weak base, and for a weak base, the equilibrium reaction we are always talking about when we deal with a weak base looks like this. That is always the equilibrium reaction that we're talking about for a weak base. It's the generic weak base equilibrium reaction. So let me look at the values given in the problem so that I can fill out this ice table. That one's pretty obvious. That is the initial base molarity. I don't have to keep track of water, and since I am not given initial concentrations of these products, we assume that they're 0, just like we did back in Module 4. Now, the only other value given here is that pH value for this. And so what I have to think about is, how does the pH relate to this equilibrium reaction? And we learned in the previous modules that from the pH, we can figure out the OH minus. We did that in the previous module. So if I know the pH of the solution, I can calculate the OH minus, and that's the equilibrium amount of OH minus. This is going to get me that equilibrium value for OH minus. If the pH is 11.21, let me get a darker color. All right, I can get the OH minus. There are two routes to get there. I think this one is easier. The pOH is 11.21 taken away from 14. Let me grab my calculator. So the pOH is 2.79, which means the OH minus concentration is 10 to the negative 2.79. Now, I can go ahead and calculate this out, but I do want to keep extra significant figures. If I do so, I probably want to keep 4 or 5 sig figs if I go ahead and plug that into my calculator and solve for it. Right now, I'm just going to write it like that. So that is the equilibrium OH minus concentration. I can now finish the ice table. Remember, to calculate K, the equilibrium constant, I need the equilibrium values of everybody. And we did this back in Module 4. Well, that means this must be plus 10 to the negative 2.79, which means this is plus 10 to the negative 2.79, and this is minus 10 to the negative 2.79. I now know all my equilibrium values. 0.24 minus 10 to the negative 2.79, and this equilibrium value is 10 to the minus 2.79. So Kb, which is products over reactants at equilibrium, is 10 to the negative 2.79 squared all over 0.24 minus 10 to the negative 2.79. I can punch that in my calculator. It's fairly straightforward. I also can use an algebra solver, or I can use a calculator. Let me go ahead and do this with my calculator. Let's see if I can get this plugged in. 10 to the, which is the inverse log. I'm going to type it in as the inverse log of negative 2.79. That is all squared. So I need to, all right. I need to, inverse log of negative 2.79. That has to be squared. So let me see if I can get my calculator to square that. That's not what I want. Ooh, I really need to practice these things. Let's see. All right, here we go. Parentheses. Inverse log to the negative 2.79. That's how you do it. End my parentheses, square this, and then divided by left parentheses 0.24 minus 10 to the, which is the inverse log, of the negative 2.79, right parentheses, equals, and your instructions are to report your answer to 2 sig figs. So I'm going to report 1.1 times 10 to the minus 5 based on my calculator. And that is indeed the answer that this question, the correct answer for this question.